Hey friends, welcome to the YouTube channel all about electronics. So in this question, with the help of the 3 to 8 decoder, one 3 variable boolean function has been implemented. So for the given circuit, we have been asked to find the simplified form of the boolean expression in a product of sum form. So if you observe the circuit, then here all the outputs of this 3 to 8 decoder are the active low, meaning that when one of the output of this 3 to 8 decoder is active, then it will become logic low. For example, when the inputs A2, A1 and the A0 are 0, 0, 0, then this D0 output will become active. And here, since the output is the active low, so that output will become 0. And at that time, if we see all other outputs, then it will remain 1. Likewise, when the input combination is 0, 0, 1, then the first output will become 0. And likewise, for the different input combinations, the specific output will become 0. So here, this X input is connected to the A2 input, while the Y and the Z inputs are connected to the A1 and the A0 inputs. And here, this each possible input combination represents the specific minterm. For example, when the input combination is 0, 0, 0, then that corresponds to minterm M0. And likewise, when all the inputs are 1, 1, 1, then that corresponds to minterm M7. So in this question, these outputs 1, 3, 5 and 6 are connected to the OR gate. And if you observe over here, then all the inputs of this OR gate are the active low. So let's say the input to this OR gate are A, B, C, D and the output is equal to F. Then this output F can be given as this A bar plus B bar plus C bar plus D bar. Meaning that when that specific input is low, then the output of this OR gate will become 1. So here, these active low outputs of this decoder are connected to the active low inputs of this OR gate. So basically, these active low outputs of this decoder will get negated by the active low inputs of this OR gate. Or in short, these bubbles will get cancelled out. So we can say that the output of this logic circuit will become high when either 1, 3, 5 or 6 output of this decoder becomes high. And that will happen for the minterms M1, M3, M5 and the M6. So we can say that this output F is the summation of these 4 minterms. And now, by simplifying the Boolean expression corresponding to these 4 minterms, we can easily find the minimized expression. So now, let us simplify this expression with the help of the K-map. So here, since the output F becomes high for the 4 minterms, so in the K-map, these 4 different minterms are represented with the logic 1. And now, by combining these minterms, we can easily find the minimized expression. But here, this minimized expression will be in the SOP form. But if you read the question, then here, we have been asked to find the minimized expression in the POS form, that is in the product of sum form. And to find that, we need to combine the zeros in the K-map. So if you observe the zeros in the K-map, then here we can make the group of this minterm 0 and the 4. Likewise, we can also combine these minterms M0 and the M2. And as you can see over here, we cannot combine this minterm M7. So here, this group corresponds to Y bar dot Z bar. Likewise, this group corresponds to X bar dot Z bar. And similarly, this minterm corresponds to X dot Y dot Z. So here, since we are combining the zeros in the K-map, so the Boolean expression which we will get is corresponding to the F bar. So we can say that this F bar is equal to this Y bar dot Z bar plus XYZ plus X bar dot Z bar. And now, if we take the bar of this entire term, then using the De Morgan's law, we can easily find the F. That means if we see the expression of the F, then this F is equal to this Y plus Z dot X plus Z dot X bar plus Y bar plus Z bar. That means for the given logic circuit, this is the minimized expression in the POS form. And therefore, we can say that for the given question, this A is the correct answer.